The first component that we usually think about when we're designing our classes is the instance data variables that are going to describe that object. So remember that the instance data variables are used to represent the characteristics or the state of the object. So that's the purpose of the instance data variables. Our instance data variables are declared within the class but outside of the method. So remember that that word declared means where we specify the type and the name of the variable. So to make a variable an instance data variable, we put that declaration statement inside the class but outside of any method. So it's just within those class brackets. Instance data variables can be accessed by all methods inside the class, so you can basically use them anywhere inside the class. And the most important thing to know about instance data variables is that every object has its own copy or its own version of every single instance data variable. So remember that the class just specifies the design, what objects are going to look like. But then when we actually go and create objects, each object that we create gets its own version, its own copy of all of those variables. Okay. So let's go ahead and actually create our die class. So I've got Eclipse open and I'm going to create a new class called die. So here I'm following my naming conventions because I have upper camel case. I just have a single word, so I don't have a second word, and it's a singular noun. When I first create my class, I just get my class header, public class die, and then I have my class brackets, and everything in between those class brackets is going to be my class body. So basically all of my class will go in between these brackets. So again, the first thing I want to think about is my instance data variables. So I'm going to declare my instance data variables inside these class brackets, but outside of any method, which is easy right now because I don't yet have any methods. So I'm going to declare my instance data variable with the visibility of private. We'll talk a little bit later in this series about visibility modifiers. So for now, just know that we're going to keep those instance data variables private, and we'll talk about why very soon. And then after that keyword private, I'm just going to declare the variable the same I would any other variable by specifying the type, in this case int, and then giving it a name. I'm going to call my variable face value, and this is following my naming conventions for variables because it's a lower camel case, lower case f, and capital V, and it's nice and descriptive like we like our Java variable names to be. So that's it. That's how I write my instance data variables. Now this class happens to just have one, but many of your classes will have more than one instance data variable. So you would just put all of those declarations just like this right at the beginning of your class. We talked about if perhaps you were writing this class for use in a graphical program, you might have an instance data variable to represent the image file that goes along with your die. Or you might have a color of the die, for example. So you might have more instance data variables that describe your object. For our example, we're going to keep things simple and just have face value. So again, all I've done so far in this class is just sketch out the design of what a die object is going to look like. Haven't actually created any die objects. But if I were to create die objects, each one of them would have their own copy of face value. They'd have their own version of that variable. So if I created two die objects, die 1 and die 2, they would each have a face value, which makes sense, right? Because if we have two die objects, so if we have like a pair of dice, each one can have its own number that's face up. They don't share that information. Each one gets its own version of the information. So die 1 has a face value, and die 2 also has a face value. Again, that's the key part about instance data variables. Every object gets its own version of that variable. So that's our first component, our first building block, the instance data variables. Those again are used to describe the characteristics or the state of the object. The next thing we want to think about adding into our class is the constructor. The job of the constructor is to create and set up objects. So remember, all we've done in our class is define what objects are going to look like. We haven't actually created any, but when we actually want to create some, we need a way to do that, and the constructor is that way. So what the constructor does is it creates and sets up an object of the class, and that object is called an instance of the class. So that's the terminology that you'll hear. An object is an instance of the class. So the job of the constructor is to create that instance. And it does so by initializing the instance data variables using either parameters that are sent in giving the initial values, or if we don't have initial values sent in as parameters, we can use default values that are defined in our class. So let's take a look at what this would look like in our die class. So here we're going to have our constructor. Actually, let me just flip back here for a minute. The constructor is special because it has two properties when you write the constructor that you have to follow. The first is that the constructor has the exact same name as the class. And the second is that the constructor has no return type. So it's not that the constructor has a void return type, it's that it has no return type. Okay, the constructor is the only method that you're going to write that has no return type. It's a very special kind of method. No return type. So when I write my constructor is going to be public, and again we're going to talk about visibility modifiers soon, and it has the same name as the name of the class, so die, and notice that there's again no return type in here, so no return type at all. And then I'll have my parentheses just like I would on any other method, and inside those parentheses will go the formal parameters. So these are the parameters or the input values that I need to set up my object. So when I think about a die object, there's kind of two ways I could go about setting up a new die. One way would be to say, well, I'm just going to have all of my dies initially, having a 6 face up or having a 1 face up. All right, that would be one way to go about it. The second way to go about it would be I'm going to have the user tell me which number is initially showing face up. Okay, so either one of those approaches are good. You'd have to just kind of think about what the purpose is and how this class is going to be used, and then choose the constructor that makes the most sense. So we'll look at what both of them will look like. So the first one we'll look at is taking in that information about which number should be face up. So to do that, I'm just going to create a parameter, and I'm going to say initial. I'm going to call it initial face value. And then inside my constructor, I'm going to use this parameter to initialize my instance data variable. So I'm going to say face value gets initial face value. So I spelled something wrong. There we go. I now am sending in my initial value into my constructor. So whenever I go to set up my die object, I'm going to say, okay, I want my die to start with a 3 facing up. And I take that value in as a parameter, and I use it to initialize the value of my instance data variable. So remember that even though right now these values are the same, my parameter only lives as long as the method lives. So when my constructor is over, initial face value is gone. I can't access it anymore. But face value describes my object, so I get to keep face value around as long as my object lives. So this can look a little strange. It's like, oh, I'm assigning a value to the exact same value, but that's not really the case because this value is sort of temporary. It just gets sent in as input, but the instance data variable, that gets to stick around as long as the object is around. So any information about our object that we want to save, we want to store, we need to put that information in an instance data variable. So this is one constructor, again, that will allow us to initialize a die object using some input from outside. Our other option would be to just have to take in no information from outside and just pick some initial value. Hey, all of my dies are initially going to have a 6 facing up. Now, we've said in the past that anytime you find yourself putting a number hard-coded inside your code, you should stop and think about whether a constant is a good thing to use in place of that number. And this is a very good place to use a constant. Default or initial values that you have in your code really should be represented in constants, with constants. So I'm going to come up here and create a constant. I'm going to call it default initial face value. This is a nice long descriptive constant name like we like in Java, and it follows the naming conventions for constants, all caps separated by underscores. And now inside my constructor, instead of initializing to 6, I'm going to initialize to that default initial face value. Remember that the point of constants is not to save us typing. We've just done a lot more typing by using a constant, but it's nice because it makes our code more readable and it makes our code more maintainable. It's more readable because a user coming in here now knows exactly what this value is instead of having to figure out what's a 6, what does that mean? And it's also more maintainable because if we decide later on that, oh, we don't actually want this to be a 6, we want all our die objects to start face up with a 1, we go to one place in our code and change that value as opposed to potentially having to change it in multiple places in the code. Okay, so again, anytime you're putting a number hard-coded into your program, think about if a constant is a good choice instead. And with things that like constructors, with default values, constants are usually a very good thing to use. So these would be our two different constructors that we could write. We could again initialize die objects using some inputted value from outside or just using some default value that we set ourselves. For now, I'm going to choose the first version, but I'm just going to comment out this second version because we might decide to use that one later on. But for now, I'm going to leave this as our constructor. So the way this constructor gets used is it'll get called whenever we create a new object using that keyword new. So when we use the new keyword, we create an object, and that's called instantiating the object, or it's also called creating an instance of the class. Java likes to have multiple ways to describe things, and this is an example of that. So when we create a new object, we use the new keyword. That's called again instantiating the object or creating an instance of the class. When we use that new keyword, three things happen. Memory is allocated, the code inside of the constructor is executed, and a reference to that memory that is now initialized with all the instance data variable values that were set in the constructor is then returned to that variable. So we'll take a look at what those three steps in a moment. So here are some examples of creating objects. So this is code that we're all very familiar with. Scanner scan gets a new scanner sending system.in as an actual parameter. And here scan is an instance of the scanner class. And we are invoking the scanner constructor with the new keyword to create or initialize that instance. So we're instantiating that object. And then here we're creating a new object of our die class. So here we have the new keyword which calls the die constructor, and we use that to create an object of type die. So for example, I would put that code inside. I'm going to create a second class, and I'm going to call it just die tester. And this class is going to have a main method, so this is going to be my class that actually runs. And here I'm going to again declare my object of type die, call it D1. So this is declaring my object variable D1 type die. That's my declaration statement. And then I'm going to initialize that to be a new die object, and I'm going to put my initial face value to be 5. So here we're invoking the die constructor, sending in that initial information. So what happens when we use that new keyword? Again, in a statement like this, and this just breaks down the pieces I just said, this is the type, and this is the variable name. So D1 is an object reference. It's an object variable because die is a class. Here we have our new operator. Here's our call to the constructor, and then that's the actual parameter that's sending the input in to our constructor. So what happens when we invoke that new keyword? Well, three things happen. The first thing that happens is we allocate the memory that's necessary to store that object. So in our case, when we say new die, we allocate that, sorry, that should have a 5 in there. We allocate the memory that's necessary to store a die. So somewhere in memory, a bunch of space is carved out and allocated as much as is needed to store a die object. Now in our case, there's not much that describes a die object. It's just one instance data variable, but you'll have other classes that are a lot more complex and you'll need a lot more space. However much space is needed for an object of that class, that space is sort of carved out. There's no values in there yet, so here you can see face value doesn't have a value yet, but the memory is allocated. So that's step 1 of what new does. Step 2 is that it goes and executes line by line the code inside the constructor. So our constructor is pretty short. It just has one line of code, but that's what happens next. So in this case, it takes the value sent in as a parameter and it stores it in the instance data variable face value. So now in memory, face value has the value of 5. Again, this should have a 5 in it. And the third step is that this address of wherever this is in memory gets returned and stored in our variable. So remember that with object variables, what Java stores in the place of that variable is a memory location or a reference to somewhere else in memory where all that information about the object lives. So that's the third thing of what new does, is it connects these things. It takes that memory location and it actually puts it in the variable name. So now the variable name refers to the place in memory where the object lives. And that's what the constructor does. So again, when we write our constructor, we want to give initial values to all of our instance data variables. For us, it's just one. And we do that either using parameters or using default values. And then in order to invoke that constructor, we use the new keyword. And that allows us to create new objects of that particular class, that particular type. So this is our class blueprint. And in our main method over here, we've actually created an object of type die called D1. Now, one last note about constructors. There's a special kind of constructor called a default constructor. It's also called a no argument constructor. So again, multiple words for the same thing, a default or a no arg constructor. And this is just a constructor that doesn't take in any parameters. So that would be like the second one we wrote here and commented out. Now, if you have no constructors in your class, so let's say I had this class like this, it has no constructors in it at all, what happens is behind the scenes, Java puts in a default constructor for you. So you never see it, it doesn't show up in your code, but it's as if behind the scenes, Java gives you this for free. They give you this default constructor. There's no code inside of it, doesn't initialize anything, but they give you this constructor that doesn't take any parameters, doesn't have any code inside it. Now, that only happens if you don't have any constructors in your class. The second you write your own constructor, Java gives you nothing for free, and you just have the constructors you've written. So in this particular class, with this constructor commented out, this class does not have a default no arg constructor. It only has one constructor, and that constructor takes in a parameter of type int. Now, if I'd made the other decision, if I had decided to keep this second constructor and not this first constructor, now my class does have a default no argument constructor. It's the one I wrote myself. So it's not someone that Java wrote for me behind the scenes, but it's this one that I wrote myself. But because I didn't make that decision and I decided to use this constructor, again, my die class does not have a default no argument constructor. Now, I'm mentioning this now because we're talking about constructors, but we won't see why this matters for a while yet until we talk about inheritance. So just sort of tuck this little piece of information back into your brain, hold on to it for later, and we'll use it when we get to inheritance. So next up, we're going to talk a little bit about visibility modifiers.